Hello ladies and gentlemen, this is Mr. Simmons again, back with the Pythagorean Theorem Part 3. Today we're going to be studying the converse of the Pythagorean Theorem. And the converse states that if the sum of the square of the legs, which are the two shorter sides of a triangle, is equal to the square of the hypotenuse, which is the longest side of a triangle, then the triangle must be a right triangle. This also means that if the square of the hypotenuse, the longest side, is not equal to the sum of the square of the legs, the two shorter sides, that the triangle is not a right triangle. So once again, we're going to be following the same steps of identifying sides A, B, and C. Then we fill in our Pythagorean theorem, a squared plus b squared equals c squared, substitute our values, and then simplify or solve. I have two examples for you to guide you through the process. Here is the first example. Our instructions tell us to determine whether the triangle with the given side lengths is a right triangle. So I have the side lengths 25, 7, and 24. Three sides make a triangle. Well, I first have to identify which ones are A, B, and C. Remember that C is the longest side, which is the hypotenuse. So I look here for the longest side, which is 25. I'm going to label it C. And so the other two must be the legs, which would be sides A and B. So the next step is write out my Pythagorean theorem. So I'm going to write out a squared plus b squared equals c squared. And now I'm going to substitute in my values. So I'm going to substitute a as 7. So I have 7 squared plus 24 squared equals 25 squared. Now I simplify or solve. So 7 times 7, or 7 squared, is 49. 24 squared is 576. Oops. And 25 squared is 625. Now I need to add these two together. And so when I add 49 plus 576, I get 625, which is equal to 625. So this checks out, and yes, this is a right triangle. So I'm going to write my answer. And I'm going to abbreviate triangle with the picture. Okay, so with that said, I can go on to the next example, and I follow the exact same process. So determine whether the triangle with the given side lengths is a right triangle. Well, this time I have units of measure, 10 inches, 61 inches, and 60 inches. Same process. First identify sides A, B, and C, with side C being my hypotenuse, the longest one. So here, 61 is the longest, it has to be C, and the other two, I like writing them in order, just A and B, and then filling in my Pythagorean theorem. So a squared plus b squared equals c squared. So a is 10, so 10 squared, plus b, which is going to be 60, that gets squared, and side C is 61, and I square that as well. So I now simplify or solve. So 10 squared is 100. I add that to 60 squared, which is 3,600, or 3,600. And 61 squared is 3,721. Now I add these two together. So 100 plus 3,600 is 3,700. And I bring this one down, 3,721. You notice that these are not true. 3,700 is not equal to 3,721. Therefore, no, this is not a right triangle. Okay, It's a very simple process. Just follow the same steps that we've been doing the whole time with the Pythagorean theorem of identifying the sides A, B, and C, writing your Pythagorean theorem, substituting the values, simplifying or solving. If they are equal, which was on this page, then yes, it is a right triangle. If the value or the numeric sentence is untrue and the values are not equal, then it is not a right triangle. I hope this helps you with the converse of the Pythagorean theorem and solving these style of problems. Thank you for watching.